billions of dollars, thousands of engineering hours, years of construction, and it all started with a few rectangles on a piece of paper. No equipment, no pipes, no calculations, just blocks and arrows. Get those blocks wrong, and nothing that follows will ever be right. In the next 3 minutes, I will show you exactly what those rectangles mean and why every engineer, every project manager, every decision maker in oil and gas needs to understand them. Let's begin. Before a single pipe is drawn, before a single vessel is sized, every oil and gas plant begins with something surprisingly simple. A few rectangles on a piece of paper. That's it. Just rectangles. Those rectangles have a name. They're called a block flow diagram, or a BFD. And in this video, I want to explain, in plain language, what it is, why it matters, and what happens if you get it wrong. Now, before you draw anything, you need to understand what you're processing. In oil and gas, we call the incoming fluid the feedstock. It could be crude oil, it could be a mix of oil, water, and gas. But here's the thing most people don't realize. The feedstock is not constant. Its properties, viscosity, water content, gas-oil ratio, all of these change over the life of the field because the fluid comes from underground, from the reservoir. And the reservoir does not report to you. As you pump oil out, pressure drops. More water comes up, more gas comes up, less oil comes up. That's just physics. So the process engineer looks at the past, the reservoir history, and forecasts the next 10, 15 years. He documents this clearly. This is called the process design basis. Skip this step and you will design for the wrong fluid. And that means massive rework. I have seen it happen. It is painful. Now, back to the rectangles. Think of the block flow diagram like Lego. Each process function, separation, pumping, water treatment, gas compression, is one block, one rectangle. You are not drawing equipment yet. You are not drawing any pipes. You are simply saying, this function happens here, then this function happens there. And sequence matters enormously. If a pump sits upstream of a separator, it's there for a reason. It's moving fluid under pressure into that separator. Now, if someone casually swaps those two blocks, puts the separator first, then the pump, on paper, it looks like a small change. But the logic is completely broken. You cannot separate a fluid that hasn't arrived yet. One simple rule governs every BFD. Flow must keep moving. Fluid needs a driving force, either pressure from a pump or gravity from height. At this stage, you're not calculating anything, but the flow logic must be intact. At the BFD stage, you also decide, is this a standard design, or does it need a licensed technology, a three-phase separator? Standard. Every contractor knows how to design one, but a urea reactor, an ammonia synthesis loop, those involve proprietary chemistry. You need a licensor. That decision is made here before a single pipe is sized. It affects your schedule, your budget, your vendor list. And finally, every block has outlets, and every outlet needs a destination. Take a separator, it produces oil, gas, and produced water. The oil goes for export, the gas goes to compression. But the produced water, you can't just discharge it. It usually gets treated and re-injected back into the reservoir to maintain pressure and comply with regulations. So you add a treatment block, then a water injection block. All of this is decided here at the BFD stage. The BFD is not a detailed document. There's no equipment sizing, no pipe specs, no calculations. It is the map, and like any map, if it's wrong at the start, everything that follows leads you somewhere you don't want to be. Get it right. And every PFD, every P&ID, every engineering decision that follows has a solid foundation to stand on. In the next video, we move to the process flow diagram, where those rectangles become real equipment, and the engineering begins in earnest. Subscribe so you don't miss it. See you there.